Welcome to dNAxt. Let's start with class A subnetting. We have done with class C and class B subnetting. You can watch all those videos on the dNAxt channel. Okay, before starting with subnetting, let's talk about class A. Class A has a range from 0 to 127. 0 and 127 are reserved. So actual range of class A is 1 to 126 and default CIDR value of class A is /8. That means out of 4 octets, out of 32 bits, 8 bits are assigned for the network and remaining 24 bits are of the host. 8 bits are of the network, means first octet is of network and remaining 3 octets are the host bits. Okay, when we borrow bits from these host octets or when we borrow host bits into network, we do subnetting. We slice up our network into, or we slice up available IP addresses into different sub network. Okay, let's start with actual subnetting. Default CIDR value is /8, and when we borrow one bit from the host portion, so our CIDR value becomes 9. When we are saying that it is /9, that means 9 bits are of the network, out of which 8 bits are the default network bits and 1 bit we have borrowed into the network so that we can slice up our network. Okay, so how many sub networks we will get? According to the formula, it's 2 to the power x, where x is the number of network bits. How many sub network bits we have borrowed over here? This is number of sub network bits. So 2 to the power 1. So actually, how many sub networks we will get over here? We will get only 2 sub networks. How many host we will get over here? We will get 2 to the power y minus 2 number of host. What is y? Number of host bits. How many host bits we have over here? We have 23 host bits. By default, it was segregation as 8 and 24. Now, since we are doing subnetting, /9 is there. We have 9 network bits and 23 host bits. So, y is equal to 23. So 2 to the power 23 is 838608. So 83,88,608, and we will subtract 2 over here. Why? Because in each sub network, one IP address is your network ID and another is your broadcast ID. So actually valid IP addresses that you can assign to your host are 83,88,606. Okay, what are the valid subnets? Since we are getting two subnetwork over here, we are breaking our major network into two subnetworks. So what will be the increment over here? So as we have done already in class B and class C subnetting, the formula is 256 minus subnet bit value. So what is subnet bit value over here? Subnet bit, only one subnet bit is there and its value, first bit's value is 128. So the subnet mask will become 255.128.0.0. So यहाँ पे subnet bit value is 128. So 256 minus 128 is 128. So increment of 128 will take place over here, and in which octet now? In the second octet. Why? Because we have borrowed the bit from the second octet, so there will be increment in the second octet only. So let's write down two subnetworks that we are getting over here. First is 10.0.0.0, and another is 10 dot 0 dot, sorry, 10 dot 128 dot 0 dot 0. Okay, so let's go through these two subnetworks in detail in the next slide. Let's talk about them. What will be the first valid host, what will be the broadcast id in these cases. Okay, so as we have just now discussed, the first IP address of the first network will be 10.0.0.0, and the next will be 10.128.0.0, because there is an increment of 128 over here, and this increment will take place in the second octet. Okay, now, let's write down broadcast ID first. As we have discussed in the previous videos as well, that broadcast ID is the ID where all host bits are set to 1. Since our third and fourth octet is purely host octet, here we will write down 255.255, because when we keep all host bits 1, the value will become 255. Okay, and the increment, the octet in which increment is taking place, the value over there will be 127, number previous to 128, or IP address previous to 10.128.0.0 is 10.127.255.255, one and the same thing. Here again we will write down the octets which are purely host, 255.255, and here when we add 128 to this number, that is 128, we get 256, and 256 is not the valid number while writing IP addresses, so previous to it is 255. This is the last IP address that we can get with this combination. 10.0.0.0, last IP address is 10.255.255.255. This is the broadcast ID of the second subnetwork. Now what will be the valid host over here? First valid host 10.0.0.1. Second valid host 10.0.0.2. This will go on till 10.0.0.255. Now you cannot make it 256, hence there will be an increment of 1 in the previous octet. So next IP address will be 10.0.1.0, then 1.1, 1.2 till 1.255. Then it will become 2.0, 2.1, 2.255 tak this will rotate. So basically simply just like your timer of hour, minutes and seconds. So initially when you start the timer, all these things are 0 0 0 0 and 0 0. Okay, am I right? So the, as we all know, we have studied it in our school days, that 60 seconds make a 1 makes a minute, right? So initially it's 0 0 0 0 0 0. So 60 seconds makes 1 minute. So basically the range of seconds means seconds will move from 0 to 59. It will never show 60 over here. As soon as it reaches 59, instead of writing 60 over here, or instead of 60 appearing over here, it will become 0 and this will become 1, 0, 1. And this will remain 0, 0. Again, this will rotate from 0 to 59. But while becoming 60, it will become 0 again and this will turn as 2. So 2 minutes. Again 0 to 59, 3 minutes. When the for every minute, seconds will move from 0 to 59. It will rotate, the second hand will rotate from 0 to 59 and then there will be an increment of 1 over here. When this will rotate, when it will become 59 minutes, then 59 minutes 0 seconds, 59 minutes 1 second, 59 minutes 2 seconds. This will go from 59 0 to 59 minutes 59 seconds. At that time, here it won't take place 60 60. Instead of it, it will become 1 0 0. Right? In the same way, here the rotation is from 0 to 255. So suppose this is seconds. So seconds are moving from 0 to 255. Instead of becoming 256, it becomes 0. This becomes 1. Again, its rotation is from 0 to 255. Then this becomes 2. Finally, it will become 255 dot 255 in last two octaves. At that time, the next will be 1.0.0. 10 will remain as it is, as it's the major network octet. We will not change this. Okay, while writing IP address, first octet will remain as it is. The host octets जहाँ जहाँ पे है वहीं पे increment होगा. Okay, so now 1.0.1, 1.0.2, this cycle will repeat once again and then it will become 2. Finally 2, then 3, then 4 and finally 127.255.255. Then it will become 128, which is the network ID of the next sub network. So this becomes your broadcast ID. Okay, in this way we are getting 83,88,608 IP addresses. Here also, first valid IP address will be 10.128.0.1, 0.2, 0.3 till 0.255. Then it will become 1.0, 1.2, 1.2 till 1.255. Then it will become 2.0. This will continue till it becomes 255.255. Then at that time, here there will be an increment of 1 from 128 to 129 and then 0 0. This cycle will repeat and then it will become 130. Are you getting it? Means for every change in the third octet, every one for increment of one number in third octet, every time fourth octet may you will get combinations of 256 IP addresses. Then there will be change in the third octet. Okay, for the increment of 1 in the third octet, again your fourth octet will show combination of 0 to 255, means total 256 combination. Again there will be an increment of 1 in the third octet. This will go on till you get 255.255 in the third and fourth octet. Then and then there will be an increment of 1 in the second octet. Okay, this is all about /9. We'll be discussing /10 in the next video. So stay tuned with dNAxt. Thank you.